So we're doing lesson 1-3, notes activity. So these are going to be our notes. So we already passed out the 12 basic functions. We're going to look at these, and we're going to answer these questions, okay? So look over the 12 basic functions and answer the following questions. Number 1, 9 of the functions have a domain of all real numbers. Which 3 do not? So look at the domains of all of them. They're right there in front of you. So which ones don't have it? Let's see. Well, the first one I come across, you can either name them or write their function is fine. I found the reciprocal function does not. So f of x equals 1 over x. The domain is not all real numbers. For that, x can't be 0. Another one would be the square root function. There's not enough room to write on here, is there? F of x equals rad x. You cannot plug anything less than 0 into that function. The other one is what? What's the last one? The domain is not all real numbers. Anybody want to guess? You see it?
Log.
Yes, natural log. I talked about that a minute ago. So that would be f of x equals natural log of x, ln x. That one right there, you can't plug in 0 or less than 0 into that function. Okay, part B. One of the functions has the domain of all real numbers except 0. Which function is it? Hey, I just talked about that. Which one was it? Yes, the reciprocal function, which is f of x equals 1 over x. Why isn't 0 in its domain? Perfect. I love that answer. It would be undefined. Okay, we would plug in 0, and that is not allowed. 1 over 0. Undefined. Perfect. All right. Letter C. Which functions have no negative numbers in their domains? 2 of them. Which ones are they? No negatives. Square root. Perfect. And natural log. Yes. Square root and the natural log ones. Natural log of x. Of these 2, which one is defined at 0? So which one's okay to plug 0 in for x? Which one? Let's circle it. Square root. I'm allowed to plug that in. Not allowed to plug in 0 for natural log. You can even check that on your calculator if you want to. Natural log of 0, undefined. No real answer. All right, then earlier this week we talked about continuity. And continuity, remember, is that you can draw your graph without lifting up the pen when you're drawing it. So which 2 functions have points of discontinuity? So there's some discontinuity here. Which 2 of them? You see them? Let's see. Which 2? Well, there's one right away. Yes, the greatest integer function. Let's just write that as f of x equals int x. And those are all jumps. Those are jump discontinuities. And then what about the other one? It's an infinite discontinuity, and that would be reciprocal. Perfect. 1 over x. Okay? Everything else is a nice smooth curve or line or whatever, and you can draw it with no breaks in the graph. Are these points in the domain of the function? No, never. If it's discontinuous, it is not in the domain of the function. All right. For the 2 discontinuous functions, at what x value and what type of discontinuity is it? Okay. We just talked about this. This one is at x equals 0. It's an infinite discontinuity. And then this one is a jump at all of the integers. X equals integers. Remember what integers are? Plus or minus 1, 2, 3, 4, and 0. Okay? Those are all integers. Okay, now last night you did an assignment on looking for symmetry. Okay, and which functions are even and which functions are odd. So remember, even is symmetric over the y-axis, and odd is symmetric over the origin. And there are 3 of them that are even. So I want you to write them down, okay? Try it, write it down. If you don't get it right, you can always erase. So write down by yourself which functions you think are the even ones out of those 12. I'm going to write them down too. I didn't give you enough room. I need to redo this. All right. I'm going to do this. Even, odd. Okay, I'm going to write down the even, and you're not going to get to see it. There are 3 of them? Yeah. And we'll compare. Can you see them? And one way at the bottom. All right, what'd you get? Did you get x squared, absolute value of x, and cosine of x? Cosine of x is even. That's pretty cool. All right, write down the odd ones now. The odd ones are reflection over the origin. And let's see what we got. I'll write them with you. So I have f of x equals x cubed, and we talked about that one being odd yesterday. It's kind of fun. Oh, I skipped one. F of x equals x is an odd function. Oh. 2 more. What you got? F of x equals 1 over x. You did that one last night in your homework. Found out that was odd. And then last one is one of our trig ones. Sine x. So cosine's even and sine is odd. Yeah?
How come the greatest integer function doesn't count?
It's because, like, if you plug in, like, let's plug in x equals 2. Y would be 2. And you plug in -2. Y is -2. I don't know. Do you think that one works?
I'm just looking at the shape.
Yeah, the shape of it.
But then the
All right, so there was a discussion that didn't say either way. People.
No, but on Yahoo Answers, they were like, oh yeah, the shape of it and the symmetry of it makes it odd, but I'm not sure.
All right. Okay, let's go with 1.4. And 1.4, we're going to do building functions from functions. Sounds complicated, huh? Functions from functions. So we studied functions a great deal in Algebra 2. And we're going to kind of do some of the same stuff, but just a little bit harder. Okay? So we're going to take functions and we're going to do a couple of things to them. Number 1 is, or part A, is that we can just do some simple arithmetic with functions. Yeah, like add, subtract, multiply, and divide. You're allowed to do that. So, for example, let's say that I have a function f of x, and f of x is equal to 2x minus 3. And then I have another function we'll call g of x, and g of x is x squared minus 1. So I'm going to take these functions and I'm going to do 4 different types of arithmetic with them. So I'm going to take f plus g of x. And when it's written that way, it's really confusing. It's like I'm taking f and g and adding it together and applying the x later. No. What all this means is to take f of x, the function, and add it to the other function next to it, g of x. So f of x plus g of x. So I'm going to take 2x minus 3 and add that to x squared minus 1. And then you want to combine your like terms. And I like to write this in descending order of exponents just because I'm used to that. So it would be x squared plus 2x minus 4. And that's it. And that would be your answer. Okay? All right, so that would be to take the sum. The next one would be the difference of the functions, f minus g of x. And students tend to miss this problem because they forget to do what? Starts with the D. Distribute, yes. Forget to distribute that minus. You're subtracting the entire function, not just the first part. Okay, so you're going to take function f, which is 2x minus 3, and we're going to subtract all of g of x, which is x squared minus 1. And when you do that, you want to distribute that minus sign to all the terms in g of x. So I get a negative x squared. I get a plus 1 and a negative 3. My 2x is right there, and so I get negative x squared plus 2x minus 2. A negative makes a positive, right? Two wrongs make a right? No? When bad things happen to bad people, that's positive, that's a good thing. All right, next one. It's terrible. I love that. Let's do the product now. F times g of x. F times g of x is the same thing as taking function f of x times function g of x. Oh, what are we going to have to do? We got two binomials multiplying together. Our good old friend FOIL. We got to FOIL this out. Okay, let's multiply. Multiply, we're going to just, it's a different way to distribute. It's called FOIL. We're going to go first, which gives us 2x cubed. Outside is negative 2x. Inside's negative 3x squared. And my last term is positive 3. There are no like terms. If you want to leave it like that, you can. Okay? It didn't say to put it in standard form. And that could be our answer right there. No problem. Alrighty, last one. So we multiplied, or we added, subtracted, multiplied. Now we're going to divide. That's right. Let's do f over g of x. And a lot of times with division in these, there's nothing to do. But they are going to ask you for the domain, so we'll do that here too. All right, so for this problem, we're going to take f of x, which is 2x minus 3. Why did I write 1? 2x minus 3, and we're going to divide that by g of x, which is x squared minus 1. But x cannot equal. See, x was fine equaling whatever it wanted to equal and all the other ones. But here, x can't equal what? Perfect. Plus or minus 1. Okay? Not positive or negative 1. So we got to do the domain. Domain for all of the rest of them were all real numbers. There's no problem. But here there's a problem. All right, so that's part A. That's pretty basic. You did that stuff last year. Adding, subtracting, all the arithmetic. All right, part B. Now we're going to do some compositions. We're going to do functions inside of functions. Compositions. And you're going to recognize this as soon as you see it, because you've done this before, and you may not have liked it. Bless you. Or you may have liked it. I don't know. But it looks like this. F of g of x. Do you remember that? Fog? Yeah. And a lot of people don't like it written like that. Because, like, what does that little circle mean? You know, that's new. As soon as you write it like this, f of g of x, that makes a little bit more sense. It's g of x is inside, it's being composed of inside of f of x. So let's go ahead and do some problems with this. All right, number 1. That last one wasn't an example, huh? Let's just stay with our same f of x and g of x from up above. F of x is 2x minus 3, and g of x is x squared minus 1. Okay? And there's going to be some things that you can do with this. You could do something like, first of all, let's do f of g of 3. Okay? We're going to pick a number, like 3. They'll pick a number for you. And then what you're going to do is you're going to take 3 and you're going to work from the inside out. Do you remember this a little bit? Yeah? All right, you're going to take g of 3, and we're going to evaluate that. So you plug in 3, and a lot of this you can do in your head. And I'm fine with that. And you're like, cool, no work, yes. So 3 goes in, and we get 3 squared is 9, minus 1 is 8. Okay, so g of 3 is 8. Now I need to find out what f of 8 is. So now I'm going to take 8, so you get the answer out of g, and you go to 8 now, or to f now, plug it in, you get 16 minus 3, and the answer is 13. Now, a lot of people think there's 2 answers. There's not. It's like a string of things until you get to the final end result. All right, so that's pretty basic. You feel good about yourself, and then they do this to you. They're going to say, instead of that, let's do f of g of all numbers that are in the domain x. So f of g of x, we can label this as a and b if you want to. And you might have to show a little work here. My son, he just got back his math test. He did really well. He got 29 out of 30, and then she marked off 1 point for not showing enough work. He got them all right, though. He was so mad. What does she have to know? I'm like, oh, you sound like my students. That's so fun. All right, so g of x is x squared minus 1. We're going to take that whole thing. We're going to pick it up. We're going to plug it into f. Okay? Now, if I had said, what is f of 5, you would get rid of the x and put a 5 in its place. See, the most common mistake people make here is they multiply stuff together. No, you're replacing. Okay? So we're going to take g of x, and we're going to plug it in to function f. We're taking that x out and plugging in x squared minus 1. Do you remember doing these? Yeah. All right, so then you get 2x squared minus 2 minus 3, which is 2x squared minus 5. That would be your answer. Okay, let's go the other way. Let's do g of f of x. G of f of x. Yeah.
2 times -3 is 6, right?
Times?
Oh.
Oh, it's minus. Yeah.
Minus.
Yep. But it is. You're right. All right. G of f of x. So let's take f of x now, which is 2x minus 3. We're going to plug that into our function g. Okay? So we're really doing, if you want to write this, you can, if this helps you. What was it? 2x minus 3? We're really doing g of 2x minus 3, because that's what f of x is. And that is equal to 2x minus 3 squared, minus 1? Minus 1. Okay? And then, of course, I'm going to ask you to simplify that. Wait, did I do that wrong? I totally did that wrong, huh? No. No, I'm okay. What did I do on my paper then? No, I'm okay. Yeah, okay. All right, so let's FOIL this out. Do you know how to do a shortcut? FOIL this? A binomial squared? Yeah, you square the first term, which is 4x squared. The middle term is going to give you negative 6x, but there's 2 of them. So negative 12x. And then you square the last term, which is plus 9. Don't forget we still have a minus 1. So our answer would be 4x squared minus 12x plus 8. That would be your answer. All right, that's composition of functions. Pretty fun. Same old stuff from last year. All right, now part C. Part C. How many parts are there, you're thinking? There's only 2 more. We're actually more than halfway done. You're going to have a lot of time to work on your homework, which is good. All right, we're going to talk about domain. Domain, you know, it's going to show up all the time. It's not going away. So if you don't understand domain, we need to talk because it's really important. Like, we're going to get to trig stuff. Like, we're going to graph sine and cosine and tangent and secant and cosecant. All these graphs, and I'm going to ask you what's the domain. So you have to know the domain the whole year as we go along, okay? So domain of the composition of a function basically is going to restrict the outputs of G so they're in the domain of F. It's very confusing. So here, let me show you an example. Number, what are we on? 3? 4? 2. Number 2. That's what happens when you do like A, B, C, D. All right, so we're going to find the domain of f of g of x. Find the domain of f of g of x, given that f of x is equal to x squared minus 9, and g of x is the square root of 9 minus x squared. Okay. So let's talk about this. Find the domain of this, okay? Now, if you were to evaluate this, if you were to do f of g of x, and you were to find out what it's equal to, you would take this function g of x, and you'd plug it into function f. So it would be the square root of 9 minus x squared all of that is being plugged in for this x right here, so it's being squared, and you subtract 9. Do you see that? It's a little complicated, more complicated than the last one. But you take g of x, which is this whole radical, plug it in for this x, so then you square it, and you end up getting 9 minus 9 with a negative x squared. So your answer is negative x squared. Okay. Now the domain of negative x squared is all real numbers, but that's not going to be the domain of f of g of x. Okay, that's what makes these a little tricky. You can do the whole thing and go, oh, what's the domain of this? No, this is what you have to do. If you're going to plug in a number, you're going to go into g first, right? So you plug in a number into function g. What if I decide to plug in 10? Am I allowed to plug in 10 into function g? We're just doing real numbers now. No, it'd be 9 minus 100. Okay, that's not going to work. So I need to find out what numbers I'm allowed to plug into g first that then go into f. That's what makes it tricky. So let's look at numbers that can go in. We need to find the domain of g of x. So g of x is the square root of 9 minus x squared, which means 9 minus x squared has to be greater than or equal to 0. And we solved these in chapter P. It's still coming back. If we bring everything over to the other side, which would probably make it a lot better, we get x squared minus 9 is less than or equal to 0. Okay? And we solved that last chapter. This is just, this is what the graph looks like. This is negative 3 and this is positive 3. And we need to find out where this parabola is below or equal to 0. So where is it below or equal to 0? What interval is that?
Negative.
Perfect. Negative 3 to positive 3. You can also think of this as, if I go more than 3 inside of here, I'm going to get, you know, a negative number. Or if I go less than negative 3, I'll get a negative number. So that would be the domain of f of g of x, because you can only plug in the numbers that are going into g first and out into f. Okay? Very confusing. Let's do one more of those. Number 3. All right, this time let's say that f of x is 1 over x. And g of x is 1 over x plus 1. And I want to find the domain of f of g of x, sorry. F of g of x. And I write them both ways. I'll write it with a little circle, I'll write it that way, either way. Okay? Let's actually find what f of g of x is too, because this one's a little tricky. So if I want to find, it's not that bad, but I want to show you like what you're supposed to do. Let's take g of x and plug it into f of x, and so you get 1 over x plus 1. Gross. Okay, you're not allowed to leave fractions within fractions, but yes, exactly. When you learned division when you were a kid, and you had to divide 1/2 divided by 2/3, you took the second one and you flipped it and multiplied instead. Okay? That's what we're going to do here. We're going to take the bottom and we're going to flip it and multiply it. Because division, 1 divided by 1 over x plus 1 is the same thing as 1 times the reciprocal. And so this is just x plus 1. That's what f of g of x would equal. And if we look at that, we think, oh, yeah, that's all real numbers. But it's not. For this problem, to find, I mean, it is for that is all real numbers. But to find the domain of f of g of x, we're going to say all real numbers except for one number. And what is that? Negative 1. So if you plug negative 1 into here, that's going to be real bad. Ooh. Let's do one more of these, because this last one's kind of fun. Number 4, and then we'll move on to the last part. You're like, what? Liar. F of x equals 1 over x, and g of x equals x plus 3. And I want to find the domain of f of g of x again. Okay? Domain of f of g of x. Now, if you were doing it kind of the way we were doing it, where we're looking at G, we could plug anything we want to in G, right? Okay, but what's going to happen if we plug in G as -3? I get 0, and then I go to plug it into F. Uh-oh, that's not going to work. Okay, so not only do you need to look at the domain of G of X, but you also need to look at the result, which is F of G of X 1 over X plus 3 is F of G of X. And we know the domain of that is all real numbers except for -3. Okay, and that's what the domain of that would be. So you need to look at both. The other ones we did, it came out to be all real numbers, but if it's not all real numbers, you have to include that too. All right, and then the last part. This isn't too bad for block, huh? So yes. All right. Block odd. What time are we out anyways? 11:15? Oh, wow, good. And this part's really quick. Okay, we're going to identify the functions. All right, we're going to go backwards. So before I gave you f of x, I gave you g of x, and then we made a composition of those functions. Now I'm going to give you that composition, and you're going to tell me what the functions were before. Yes! Before they composed them. It's not bad. It's not bad at all. You're looking really for an inner and outer function. She's all, no. All right, number 5. Here we go. Let's say that h of x is equal to f of g of x. Okay, h of x is equal to f of g of x. And in this problem, h of x is the function 5x plus 1 cubed. I need to find f of x and g of x. Okay? And there's no cheating. You can't use x for either one, okay? Because people will do that. They'll make f of x be the whole thing, and g of x is just x.
Excellent.
Yes, you can't do that. X cannot be an answer for either one of these, okay? All right, look for an inner and outer function. So here's my inner function, and cubing is my outer function, okay? So the inner function is going to be the inner function of f of g of x, which is g of x. So g of x could be 5x plus 1. If I'm going to take 5x plus 1 and get it cubed, well, then f of x is what? X cubed. It's not bad, right? I know, at first you're like, whoa, how are we going to come up with that? But you're looking for an inner function, which is the inside part. You're plugging in to here. All this gets replaced, and it's cubed. It's not bad, right? Right, Jeanette? Not too bad. All right, letter B. You try one. You want to try this one? Sure. H of x equals 1 over x plus 1. And you need to find f of x and g of x. And neither one of them are allowed to be x, okay? That's just not allowed. I know there's really no inner, outer, but there kind of is in a way.
Wait, are we still doing the thing where it's like h of x equals f?
Yes. So right here, h of x equals f of g of x. And then we're given h of x, we have to find f of x and g of x. Yes, Justine, you have it? Oh, what is it? What do you got?
F of x is 1 over x, right?
Yes, that's what I got.
Is x plus 1?
Perfect. Anybody else get that? Yes. I mean, yes. Okay. X plus 1 is g of x, which goes into there. It becomes that. Nice. Okay.